let's solve part C in this video now. So show that the relationship between the consumer surplus and producer surplus is the following. 2 times the consumer surplus equals to the producer surplus. Now, we're going to use the same methods of finding the area using integrals. Now, what is the producer surplus? Well, we know is the area between the supply curve and the equilibrium price over this range. So what is this range? Let's see. What is the integral that we're looking for? It's a definite integral, right? It's a definite integral between the boundaries of 0 until the equilibrium quantity. 0 until the equilibrium quantity. We saw in the previous video that the equilibrium quantity is lambda, so from 0 to lambda. Now we have the area between the equilibrium price and the supply curve. What is the equilibrium price? We also calculated it to be equal to 8 times lambda square. So we will have the difference between 8 times lambda square over here, 8 times lambda square minus the supply function. What is the supply function? Well, let's see over here. The supply function is 2q square plus 6 times lambda square. So we will have over here 2q square plus 6 lambda square, all of this dq, now let's solve it over here below to get some more space. What is 8 lambda squared minus 6 lambda squared? That's just 2 lambda squared minus 2q squared dq. So let's write it below. We will have the definite integral between 0 and lambda, and just as we said, we have 2 lambda squared minus 2q squared dq. Now let's integrate every term. So we will have the boundaries between 0 and lambda, and we now integrate the first term, which is going to be the integral of 2 lambda squared dq. Well, that's just 2 lambda squared times q, and then we do that for the second term as well, minus 2q squared dq. So we have minus 2 times the integral of q squared dq, that's just q to the power of 2 plus 1, which is q to the power of 3, divided by 3. Now we close these brackets, right? We close these brackets, and we're going to start substituting values. So we'll substitute lambda into the variable, into the quantity, see what result we get. So we will have the following. We will have 2 lambda squared times lambda, right, instead of q. So let me just change colors real quick to keep track of the substitutions, times lambda, and then we go minus, so minus 2 times, we substitute lambda into the following expressions. It will be lambda cubed divided by 3. So lambda cubed divided by 3. We close those brackets. Now let me just close these brackets. And minus, we substitute 0 into all of that. But when we substitute 0 into the quantities, we will just get 2 times 0. And over here we have 2 times 0 over 3. So the entire expression is just going to be 0. Now, what is the result? Well, we have 2 times lambda squared times lambda, that's 2 lambda cubed, minus 2 times lambda cubed divided by 3. How can we write this differently? Well, lambda cubed is the common factor. Lambda cubed over here is the common factor. So we have lambda cubed, and in brackets we're left with 2 minus 2 over 3. 2 minus 2 over 3. Now we can expand this, right? We can multiply this by 3 to have the common factor. So we have as a result lambda cubed times, what is 2 times 3? 2 times 3 is gonna be 6 minus 2, that's just 4 divided by 3. Now let's compare this to the consumer surplus that we found. This is lambda cubed times 4 over 3 equals to the producer surplus. The consumer surplus that we found is equal to, where was it? Is equal to 2 over 3 times lambda cubed. Let's just crop this to compare it with the producer surplus. So crop it and go over here below. So paste it right next to it. Now we want to see whether 2 times the consumer surplus equals to the producer surplus. So let's multiply the consumer surplus times 2. What do we get as a result from here? Well, as a result we get 2 times 2 over 3. 2 times 2 over 3, which is 4 over 3 times lambda to the power of 3. 4 over 3 times lambda to the power of 3 is the exact same thing as we have over here. So yes, it's equal to the producer surplus. We proved it and we are done.